Okay, welcome to International Institute of Non-Destructive Testing. Today we are going to discuss on radiography. So here we are discussing lesson number two, the penetration and absorption properties of X-ray or gamma ray. Uh, now this X-ray and gamma ray we are using for industrial radiography. Because of its penetrating abilities, because it passes through material, it passes through thickness, so that's why we can use this X-ray and gamma ray, because passing through material, that means penetration. If it is passing through higher thickness, then we can say the penetration is high. If it is not capable to pass through higher thickness and it will pass only in 10, 15 millimeter, then we can say the penetration capabilities of the X-ray and gamma ray is less. Now this penetration capability depends upon energy of the X-ray or gamma rays. Now energy is related to frequency and wavelength. If suppose the ray having shorter wavelength, which will have higher frequency, and higher frequency will have the highest energy, and that higher energy will penetrate bigger thickness, or we can say higher thickness. So X-ray and gamma rays possess the capability of penetrating material. In passing through matter, the amount of absorption at any point is dependent upon thickness and density at that point. Means suppose if thickness is higher, then more absorption. If suppose density is higher, then more absorption and less passing through it. So when this variation is detected and recorded on film, a means of imaging the internal structure of the material is available. For example, suppose we have one specimen, and in that specimen there is one defect. A defect means there is a defect having ear, so there is less density in that particular area. So in that defect area, less absorption within the specimen and more radiation will reach on the film. So more radiation will if reaching on the film means more ionization take place, and we are getting the black image. So more ionization means more black, more density. So this is the principle of radiography. Means, so in short we can say differential absorption. If there is any defect, there is less absorption, and it's adjacent to defect, it is more absorption as compared to a defect. So on our film film have silver bromides emulsions. Okay, there are small ions of silver bromides available there. So when this X-ray or gamma ray reaching on the film, the ionization take place. Ionization means either removing or adding electron to a silver bromides atoms. So we will get the latent image, which is not visible, but the density variation is detected and recorded on the film. So in terms of ionization, and after the processing, after developing, we are getting the visible image on the radiograph. So the latent image produced in the film becomes a shadow picture of specimen when the film is processed. Now let's see here. Here is depict. So here less absorption of radiation, and here more radiation reaches on the film. So more ionization take place. See here. Here thickness is less. So more radiation reaching on the film here. So more ionization take place. So more film will be the black. So what is the radiation? X-ray and gamma ray are the family of waves that are also called electromagnetic waves. So this is the electromagnetic spectrum, and here is the higher frequency, and so X-ray on higher frequency. So we are getting shorter wavelength which will easily penetrate. So here again we will discuss this spectrum is arranged in the order by frequency of the wave. The waves with lowest frequency are listed at the left end of the chart, while the waves with highest frequency are at right side. So we can study here visible light and X-ray gamma ray are members of electromagnetic spectrum. They have the things in common. So some of the things in many things same in common. So what we will do, the first thing, travel at the velocity of light. So visible light and X-ray or gamma ray, both traveling at speed of velocity, the travel at the velocity of light. Then 183,000 miles per second travel in straight lines, not affected by magnetic field, will expose photographic film. And now we are going to discuss here wavelength. Wavelength is described as the distance between peak of the wave. These waves can vary tremendously in length. Some radio waves are several miles long. X-ray and gamma ray are measured in angstrom unit. The wavelength is measured in angstrom, and angstrom unit is equal to 10 power 6 billionth centimeters. 1 centimeter is equal to we already know 0.394 inch. Now see, now this is the rays passing through material in the terms of cycles. Now one wavelength means this point to this point we can say wavelength, and the number of cycle for wavelength also we can say one cycle, and the frequency means number of cycle completed in 1 second, and velocity means we can say speed of rays that we already saw. Okay, the frequency is described as the number of electromagnetic waves that passes a given point in 1 second. All electromagnetic waves travel at the same velocity. Okay, the frequency is measured in cycle per second. A cycle being one complete wave through or peak to peak. Now see here, let's see here A, B, C, and in case of A, there are 1, 2, 3, 4, 5, 6, 7, 8 cycles. In case of B, there are 1, 2, 3, 4 cycles only, and in case of C, this is one and this is two cycles only. So the frequency of A is higher than frequency of B. Frequency is B higher than frequency of C because because more cycles means more frequency. So this is the simple things there. The frequency and wavelength of electromagnetic waves are inversely proportional. That means if we increasing frequency, wavelength will be shorter. This means that when increases, the other decreases by a proportionate amount. Double one and the other is reduced by one half. All X-ray and gamma rays are considered to have the same amplitude or height of the same energy peak with each wave. It is true that each wave of the two waves has an equal energy. They do have different frequencies and wavelength. In the figure shown, the high frequency ray has 4 times as many waves as low frequency. There were 4 times more energy peak. So see, this is the high frequency and this is the low frequency. Here only two energy peaks here, but here 1, 2, 3, 4 energy peaks are there. So the most important difference to the radiographer between light rays and X-ray gamma ray is their penetrating ability. Because X-ray will penetrate through matter, but our light will not. Our visible light will not penetrate through matter because of wavelength. Because of longer wavelength, it will not penetrate through matter. But in case of X-ray, the wavelength is very short. In case of gamma ray, the wavelength is short. It is easily penetrating capabilities. Visible light is stopped by opaque substances as X-ray have such high frequency and short wavelength, they are also able to penetrate opaque object and expose photographic film. Means X-ray and gamma ray will pass through opaque object, it will pass through steel, it will pass through aluminium, it will pass through copper, it will pass through any material. So depth of penetrating of rays depend on the kind of material in object and the energy of the ray. Now the penetration through the matter. Now penetration through the matter means penetration through the job, it depends upon thickness of that job, density of that job, and energy of incoming rays. If energy of incoming rays is very less means longer wavelength, and it will not penetrate in higher thickness, in bigger thickness. But suppose energy is high, that means shorter wavelength. If wavelength is shorter, then it will penetrate more, or it will penetrate on bigger thicknesses. So energy is related to penetration power, and also it depends upon thickness of object, and also it depends upon density of object being radiographed. Now see here, the both thicknesses are same, but iron having less density as compared to lead. That's why in iron more radiation reaches on film, and lead less radiation reaching on film, because lead is a high dense material as compared to iron. So remember from the spectrum that X-ray is dependent on frequency and short wavelength. The higher energy is obtained from X-ray and gamma ray with high frequency and short wavelength. So it easily passes through matter. X-ray and gamma ray of the same frequency and wavelength are identical properties. Means X-ray and gamma ray, uh, if the frequency is same, then wavelength will be same and have identical properties as well. Also important in using X-ray and gamma ray is characteristics of traveling in straight line, because both rays traveling at straight line. So it is the rays. Also the radiation produces the image of specimen just as shadow picture of object can be produced with strong light and a screen. Let's see the image with visible light. Suppose here is this candle and this is object. Then we will see here dark because the light will not pass through this object. That's why we are getting here black. But in case of X-ray, this source is here, so the radiation will pass through this object. So we are getting here white, and the surrounding area more black, because surrounding of this object, more radiation will reaching in this area. So this area is more black, and this is we are getting white because less radiation reaching here. Less radiation reaching here, that means less uh, less ionization take place. That's why less black, and this surrounding more radiation reaches on this surround adjacent area of this object, so more black is there. So X-ray and gamma ray can expose photographic film because of their ability to ionize material. When the radiation penetrates the film is exposed because the ray ionizes the thin silver bromide grains in the film. Now the X-ray film, X-ray or gamma ray films, there are silver bromides emulsion on the top surface of the film. Okay, so 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 we can discuss these things. Ionization of the film emulsion forms a latent image which is developed during later processing of the film. The image will be formed there. Image in the sense that the ionization difference. There is adjacent area ionization rate is different, and on the particular defect area there is ionization rate is different. So if there is any defect, then more X-ray or gamma ray will reach on the film, and more radiation, more ionization take place, and more ionization means more density, more blackening of the film. So that, but that film, that image we can't see. We can see only after developing the film. So the specimen itself an important consideration in making a radiograph. Enough rays must penetrate the object to form an image, but too many rays will overexpose the film. If suppose more radiation came more and more, then your total entire film will be black. So we can't identify the defect. Because we have to send optimum energy which will penetrate the thickness only. Now see here, this is the lead here, and here is no any thickness is, that's why here, yes, see here is white area because radiation absorbed in the lead. Here radiation directly passes through the film, that's why more radiation on this area, so your film will be black. Here less radiation reaching on the film, that's why your film will be white. Now the absorption is the ability of specimen to block the passage of X-ray through material. Hmm. Here blockage of X-ray or gamma ray because of this absorption properties of this material, and this depends upon density and thickness of this specimen. When the film is developed, the exposed portion turns dark while the unexposed portion will be clear. Now let's see here. Here is the defect. So defect means there is no there is very less density because of here very less density. So less absorption and more radiation reached on this film here particular area. So more ionization take place means more black. So we are getting defect always black spot here. So this is the adjacent density, and this is the defect density more dark. Okay, why more dark? Because here less absorption, so more reaching on the film. So in this particular area, more radiation reaching on the film, more radiation reaching on the film. That means more ionization take place. Ionization means removing or adding of electron in silver bromide atom. So the lattice image will be formed, and after developing this image, we will get the black spot here. So the formation of an image film depends upon the amount of radiation received by the different section of the film. Now see, this is one section and this is another section. So this one section having uniform density, and this one section, this is your defect. So different densities. As shown in the figure, discontinuities such as would represent the thickness differences in the specimen and will appear as a dark spot on the developed film. Now, if the discounting shown above had been inclusion that has more dense than the image on the film would have been lighter at that spot. Means you just consider we are doing we done GTAW welding for weld joint, and we are doing radiography for that. So in GTAW welding there are chances of tungsten inclusion. Now you know the tungsten has high density as compared to steel. So in our job, suppose there is tungsten inclusion, then what happens? There is more absorption because of tungsten and less reaching on the film as compared to surrounding area. That's why we are getting light indication, or we can see we are seeing lighter indications. So X-ray would have been absorbed by the dense inclusion. Uh, so uh, I hope you understanding this lesson. If you have doubts, or if anybody want to more clarification, so please write us on iindtpune@gmail.com, or also our contact numbers are there. So we are always happy to assist you. Thank you very much.